The wire in this problem carries electrons moving from the west to the east. Because of their negative charge, the current is in the opposite direction, and we're asked to find the magnetic field at a distance 4 centimeters directly above the wire. If we call this a side view of the system, a point above the wire is here, and we can use the right-hand rule to see that the magnetic field at that point is directed into the screen. The magnitude of that magnetic field can be found using Ampere's law. It's mu naught I over 2 pi r. If we separate the terms, we can then come over here and evaluate the current I. That's the amount of charge crossing a section of the wire per unit time. The problem statement tells us the number of electrons per second crossing a section, so the current is that number times the charge per electron. And we can calculate, finding that it's 1.31 amps. Now we can return over here and evaluate the magnetic field magnitude. The quantity mu naught over 2 pi equals 2 times 10 to the negative 7 Tesla meters per amp. And we can substitute the current and the distance above the wire to find that the magnetic field has a magnitude of 6.55 microtesla. And the direction, as we saw above, is into the screen. To relate that direction to a compass direction, let's draw a top view of the setup, which over here we can represent as looking down on this side view from above. And now in the top view, we can see that the magnetic field is directed up the screen, which is in the north compass direction. So the magnetic field has the magnitude we found, and it is directed to the north.